This is the presentation from the SDS Industry Consortium this last April, and we'll be using SDS Physical for Inventor, P4I, and talking about SDS fundamentals with Inventor. Fundamentally, SDS P4I places Inventor components into the Inventor assembly. It places them from any level, any higher level of assembly. These components are on-the-fly components like linear length parts like cable and bus, or they can be placed as individual parts like fittings and bolting assemblies. Today, we're going to review the placement of SDS components. We're going to take a look at the component location in the Inventor browser and what we can do with that location. We'll use model states to path cable and bus. We're going to work with model states and have some trickery in there. It'll be fun. And we will show the proper method of placing bus elbows and running bus to those elbows. When we place components, they attach to the Inventor occurrence in the assembly. For above grade components, the items are placed to the lowest common assembly. For below grade components, the items are placed in the assembly containing the sketch. SDS components may not be placed in the location or in the assembly the user wants them to be in. Using normal Inventor methods, you can slide that component from one assembly to another up and down the Inventor browser. If the component has assembly constraints, you should always confirm that the Inventor constraints are not broken after moving. You'll find about 90% of the time it's going to work fine. And I would even say higher than 90, but I want to be conservative. This does not move the part in the Windows folders. It only moves it in the assembly of the model. Model here, I have the model open, and we're going to place a fitting all the way down onto this part. So this part is buried down here. It's in the assembly. And we're going to place a component on there from the highest assembly. And the reason I'm working from the highest assembly is to show that you can work from the highest assembly. You don't have to work from the highest assembly. And with that, I'm going to zoom in here and I'm going to place a component. I'll come up to above grade tools, come into browse for a fitting, and I'll place that component. I'll come into fittings. I'm going to place this component here, this fitting. I'll say open. And what it's going to say to me is select a NEMA face. So I can select the NEMA face. And here you can see 4 holes placed on here. That is a NEMA face. So I'm picking the NEMA face to attach to. And with that, I'm going to pick that face. So what has happened here? So let's look at what has happened. We've placed this fitting. So I'm going to change my selection set to that fitting. And we'll find that in the browser. So let's go find in the browser. And you can see where it is here. It is part of this assembly. So we placed it from the highest assembly, and now it's placed to the lowest common assembly, the lowest assembly it can place to. We'll go look at that, and that's what it placed to. We selected the NEMA face, but what we don't know is what the NEMA face is of the individual part. So I'm going to open up the part, and this is where we bring in the work geometry for Inventor. We bring in the work geometry, we create a work plane on the NEMA face. So that work plane is on those 4 holes, the NEMA arrangement. And that is what Inventor is looking, SDS is looking for. It's looking on that fitting. It looks for that NEMA face plane to find the 4 holes. And then when we place it into the assembly we are placing it, we pick the NEMA face. So I'm going to do that again. I'm going to come up here, browse to fitting. And I'll come in and grab the EVH again, say open. And I'm going to place it on this NEMA face underneath. So that's a NEMA face too. And now I can place it on there. So now I got 2 fittings. I'm picking the NEMA face. And that item is placed in the lowest assembly, the lowest common assembly. So we may not want it in that assembly, because if we look at where that assembly is, it is way down here, and maybe we want it in the island assembly here. right? We might want it in that higher assembly, not down here in this assembly. So if we want to move it, what we can do, we can grab it and we slide it up and I'll move it here. Now this is a scary window, but we can not be afraid. We look at this, and I'm joking. We look at this and it says, just be careful, right? And I'm going to say, yeah, I want to move it. So now that fitting is now in the higher assembly. It's no longer in the lower assembly. Let's find that. It's no longer in this assembly. It's in that higher assembly. You can see it how it's not green. So we moved it from one assembly to another. We can do that with the one we put underneath there. So if I grab this EVH, well, that's not it. Find in browser. I'll move it from this one and I'll move it up into this one. Same window pops up. We don't see any health issues up here with the red cross. We can find the part in the assembly. We're going to find in browser. We're going to look at those constraints, and those constraints are fine. So 9 times out of 10, this is going to work, and it usually works if you follow the substation modeling strategy. So what we're going to do now is place a cable. We're going to place a cable. When we place the cable, it will be placed in the lowest common assembly. Like the bus, if we're running linear length bus, any type of bus or any type of cable, it's going to be placed in the lowest common assembly. Where we're going to place that cable is going to be between, in the area we're working in, between these 2 points here. These 2 points are in 2 different islands. So again, we're in the highest assembly. We'll come into the bay assembly, and you're going to see we have that assembly and we have this assembly. Those are the 2 lowest common assemblies between that cable. So let's go ahead. We're going to place that cable. We'll come up top here and we'll pick a settings. We'll have our settings of the 500 MCM cable with a 8% sag. The sag, we don't calculate the sag. The sag is calculated by others, and we just have the input here. And of course, the cable is completely configurable for its metadata. And I'll hit save on that. And I'm going to pick two fittings to add cable. So I'll come up here. I'm going to pick 2 fittings to add cable. And I'll pick this fitting to this fitting. And there's our cable. So we have a cable. If we look at the cable, it is a native Inventor spline. It's just a spline. There's nothing special to it. And it has a linear length to it. And that's the true length of that spline. It has the material we want. It has the metadata we want. But let's go look and see where this cable is. I'm going to find it in the browser. And we're going to find it here. And I'm going to expand it. And you're going to see that, first of all, it has the thumbtack, so it's grounded. There's no constraints on it whatsoever. And if we don't want it in this location, we can just do what we did before. We can move it up or down the browser to where we want it to be. But it is in the bay assembly. You notice that it's not in this island. It's not in this island. It's in the lowest common assembly. It's not in the general arrangement. It's in that assembly there. And if we didn't want it in that assembly, we can do like what we did with the other item. We can slide it to wherever we need it to be. Being that it's grounded and it has no constraints, it's not ever going to have anything broken with that, because a number of items SDS makes are grounded. There's no constraints to break. We'll look a little further into this cable being placed here. How does the cable know where it's going? If you look at what it's attached to this fitting, and it's attached to the fitting over here. So it's attached to these 2 fittings. You can see I have the work points turned on now, and those work points are in the fitting. That cable is going to see the fitting, and SDS is going to go through those 2 work points. So I'll open that up. Open up the fitting and you'll see those work points in here. Let's change this to wireframe. And you can see we have work point cable, and that's going to be the destination. And we have guide point, and that's going to be the guide point where the cable is going through and then coming into the hosel here. So that is how it is being placed. So when we're placing a cable, it looks at the fitting and it knows the path by the work points. It looks at the assembly and it knows where to place it by looking at the assembly that each fitting is in and placing the cable in the lowest common assembly between those two fittings. And with that, that's how that cable is placed. For below grade components, the components are placed in the assembly containing the sketch. And that's what we're going to work on here. You can see I have two sketches in blue. We have a trench sketch and we have a conduit sketch. If we come into the browser, you can see I have a conduit assembly and a trench assembly, and each of those contain the sketch. I can expand the trench, and you'll see there's a 2D sketch in here. Same as the conduit, I can expand the conduit. You can see I have the sketch in here. And what we're going to do, we're going to place a piece of conduit. I'm going to take a look at it. Again, I'm running from the highest level of assembly and just showing that you can run from this high assembly. You don't have to run from this high assembly. You can run in the conduit sketch itself, if in the conduit assembly itself, if that's what you prefer, or another assembly that contains the conduit assembly. But right here, I'm going to place this item. You can see I have two sketches here. That's my conduit stub out. That's a little bit higher than where my sketch is, and that's going to tell SDS how far to stub out of the ground or stub above the conduit sketch. The sketch itself, I typically always build it on the XY plane. If you look at the XY plane, that's going to be our top of concrete, that type of idea. That's the substation modeling strategy, and that's what the sketch is based on. It's not the depth of the conduit. The depth of the conduit is going to be different. If I want to know what depth I want to come into, so in this case here, I'm going to run into this pull box. So I'm going to pick a depth here. If I come in here, I'm going to take a measurement. Because we're following the modeling strategy, the XY plane is our reference plane, and that's what I'm going to work with here. So let's come in, we'll come up here, we'll come from our XY plane, which is a reference plane all throughout the model because we're using the substation modeling strategy. And we're going to see what depth this is. So that's 42 inches down from the XY plane. So that's the depth we want that piece of conduit. If I come up to the below grade tools, come up to settings, we're going to look at conduit depth. Oh, I have it at 42 inches below. And I want the rigid conduit size to be 2-inch with a 9.5-inch elbow, radius elbow. So these are the numbers I'm going to use. I'm also going to place my conduit in lengths, in 10-foot lengths. We have the switch turned on for that, and I'll hit save. So I'm going to come in and I'm going to pick my two pieces of sketch. I need to pick the drop plus the path. So I'm going to pick drop plus path. So I'm going to pick the drop, which was this higher one. That's the stub out, how high the conduit's going to stub out. And I'm going to pick the path. I'm going to zoom out so I can pick the path and we can see it run. And again, I'm in the highest assembly, and these pieces are going to be placed in the conduit assembly where the sketch lies, wherever the sketch lies. And you can see it's coming in. It follows the sketch exactly where I want it. It's coming right into that hole, and there is our item. If I come down into the conduit assembly, I'm going to right click, open that up, and you can see there is my conduit pieces. I got 10-foot lengths, and I have an odd length to make up the difference in length. So that is placing the conduit. You can only delete the conduit from the assembly that it belongs in. So if I wanted to delete that conduit, I'm going to hit that, and that whole conduit will be deleted. If I want to run it again, I haven't changed my settings, so I'll run the same conduit from the conduit assembly, and it will just run again. It's that easy to run. If we want to run trench, it's the same thing. So the trench will run from the highest assembly, and we're going to run that trench here following these two paths. I have this set up to do not a miter, although I can set it up as a miter if I attach those two pieces of sketch directly end to end. But I get a lot of people building them with a butt connection. So that's what we're going to run today. I'm going to come into my trench or my settings. I'm going to check my settings for the trench. You can see it's T's, L's, and X's, and I'm using the one that's built in. This can be configured for any type of trench. Right now, it's just configured for like a generic trench, and we're going to place this family in. We have a choice once it brings in what size of trench piece we want. So I'm going to come in here and say save. And I'm going to pick trench from sketch. Again, it's going to place the trench pieces in the assembly that the sketch is in. So I'm going to come up here. I'm going to pick that sketch, and it's going to find the two lines that we need to. But first, it's going to tell us what size, model size we want. Again, this can be configured and can be have multiple types of families of trenches in here. So I'm going to pick 3012, and I'll say done. And there's our trench placed. Where is it placed? It's placed in the assembly containing the sketch. If I find this in browser, you can see it's here. If I come up, it's in that trench assembly. Right click, open, and it's in that trench assembly. If you're looking at it, this case here, I have the sketch below the XY plane. Typically XY plane is top of concrete, and in here I have it just slightly below. The idea is to put this on grade. It's probably 6 inches below that XY plane, so it's probably on grade. If you look at the model of the trench, it's hanging from the top is the XY plane. So it's tough to say hanging from the top, but you can look at it here. You can see the XY plane is at the top, and that's how that piece is being placed. If you put this XY plane at a different elevation, it's going to move the elevation of that trench, of course, because it's all together in one. So that is placing it in here. Again, if I put my two lines point to point here, I can get a miter for that trench. I hit more feedback now to do butt ends with trench than to do miters. I think miters are slightly more money to do in a station. So let's talk about model states and occurrences. SDS places the component onto the occurrence of the part. SDS uses the Inventor work geometry found on the component occurrence. Model states are occurrence specific. So by manipulating the model state, you can manipulate where the Inventor component attaches to. And specifically when you're using cables and bus, this can be very helpful. So let's look at what we can do with model states in occurrences. So here we are playing with model states in occurrences. You can see we have two of the same items here and two of the same fittings here. So these are two occurrences of each. So if I go in and change anything, so let's go in to change this offset 1, you'll see the work features change. So I got work features out here now. Remember, we need bus and bus guide. Here we got cable and cable guide. So if I do an update on these items, they're going to go to these work features of this occurrence. So let's update the run. Now my bus is bending over to that occurrence of those work features. So we'll update this run. And the same thing, you can see it's gone over to that occurrence. If we go into another one, now I have the occurrence of this one back in the home position, and this occurrence way over here, I can update this run. And I can update this run now. You can see it's changing the location of the paths. If I come into the offset all, I'll update this run, and I can update this run. So what I'm showing you is a fun example of working with occurrences in model states on the work geometry. So when using model states, it allows for flexibility when you're placing your fittings. To be a little more practical with model states and occurrences, we're looking at this ground lug where we have a model state flip points where we place the cable entrance on the left side, and we have a model state primary where we create a model state where the cable entrance is on the right side. And this can be very handy when you're coming in and you have a directional point on this fitting. You want to have that directional where you're coming in from the top right here down, or you might have an orientation where you're coming more from the left. So you can use that right into that part. This is a direct screenshot from the document SDS part automation requirements. Okay, to be a little more practical, let's look at this cable splice. We have this fitting in the middle that has two model states in it. We have side B and we have primary. You can see that we can flip them back and forth. If I come up here and I'm going to run a piece of cable, I'm going to pick fittings. So I come through this fitting, and this fitting, and I'll hit enter. And you can see I have a path that's quite nice. Now I'll flip the my model state to side B, I guess, or primary. Let's say primary, and I'll come up here, here, and here, and enter. So here I'm able to use this single fitting to make a very nice cable splice. If you look further at it, we have our ground clamps. We have two ground clamps. This ground clamp, just like what we were looking at previously, is flip points. And you can see the points are on that side. I'm trying to turn on the work features. And here, this one is on the other side. So we're able to place it very nicely in this manner. It's a little more practical on this one. Okay, we're just going to look at this fitting just a little bit closer. I'm going to right click and open it. And there's the fitting. And you can see we have 3 points in here. So what I did just in this case is I've added a through point. What that through point does is it keeps the wire straight as it comes through. So the wire is going to come through. It's going to end at guide point and come in from the guide point and end on cable. So it's going to come down here from the top. It's going to come through, and the through point allows it to come in a straight line between these 3 points, and it straightens out the cable by adding the through point in here. So if we change to side B, we have the through point changes as well, and it will, when we place the cable, comes in nice and straight through there. And that's how we get this such a nice straight edge coming through our fitting here. Placing bus pipe elbows can be confusing. The work geometry that we use can only be bus axis, or bus guide. There's no bus 1, bus 2, or bus 3 items like that. Bus fitting misalignment, what to do. And we'll review that. And why not to use flex conduit tool for placing bus, because you will not get an accurate bus pipe. So here's a little jig of bus elbows, and you can see with the bus elbow, I'm going to open that up, and we're going to take a look at where the work features are. And I'll come up to view, and we're going to do a visual view, a wireframe. We're going to see that the bus point, the bus work point, we have bus guide, and we have a bus axis. The axis tells the SDS what direction the pipe comes in. So it's going to come along this axis to meet up with the bus point. The bus guide tells it which direction to come in. So it will only come in from the left to the right in this case. We'll go through the bus guide along the line to the bus point. When we want a bus point in here, we don't put it out here because we only have one bus. So let's come in and look at that. If we come in and let's get the right angle. When we come in here, we look at another bus axis, and that is where we place the bus point at the junction between those 2 points. And then when we place our piece of bus, we place it with a negative offset. If we measure this from the bus point, to the face here, we see it's 1.75. So that's going to be a negative offset. When we place our bus, it's going to be a negative offset of 1.75 so that it fits on this sleeve. So let's go back into our bus elbows. So if I'm going to place a piece of bus from here to here, I'm going to place it with a negative offset. So we'll come up to our settings, bus. I'm going to place 4-inch round bus, and I'm going to have an offset on this side because this is going to be my first pick, and we're going to go from that bus point along that axis to this fitting. And I'm going to have an offset of negative 1.75. On the other end, I'm going to go directly to the bus point, and we'll look at those bus points. I'm going to change these values. That's going to be 0. And I'm going to use this equation. If you look at this equation, has an IN on the end. It's just a normal parameter equation for Inventor, and this gets copied right into that parameter field. And I'll hit save. Now, when I place my bus point, before I do that, I'm going to look at my bus fitting. I'm going to right-click, look at the eye properties. And what I often do, I'll put in what offset I need. So that offset should be 1.75 because it's a negative offset. So maybe we should even put a negative in front there, right? Just to stress that it is a negative offset. So that's going to be our offset. I'll apply that. So that's that type of information we can put right in the eye properties of the fitting. So now when I place my bus, I'm going to pick 2 fittings to place bus. I'm going to pick this fitting to this fitting. And there's my piece of bus. I have a negative offset here. So I have room for my weld prep or for my weld. And over here, you can see it's bent. And it comes up into here and it's bent twice. If you look at this, it's level. So it's curled up and bent, and it ends at the, let's see that fitting, at the bus point here. Let's try and get that. See the bus point there, it ends on that bus point. So this idea, this piece of bus is not straight, and you'll never bend a piece of bus like that at site. Sometimes we do get fittings misaligned, and that's due to the many different types of fittings and offsets, and that's something they do at site. They don't always have a perfect alignment of fittings. We can try to do that in our models, but occasionally we can't. So instead of doing this type of thing of pick fittings to add bus or pick bus, because the bus tool is going to try and bend to what it needs to do. We're going to delete that run. Come on, delete. What we're going to use is pick bus point to bus point, and this avoids that item. So it's just going to ignore the bus guide. It's going to ignore the bus axis, all that. It's just going to run a pipe from those 2 points. So I'm going to run a pipe from here to here, and it's going to run exactly directly to that. There won't be a bend in here. It'll be straight, and it's straight on an angle to that bus point. So a lot of times we use this for things like spheres, and in this case, we're using it for a misalignment tool. If we instead, what some users do, and I'm going to minimize, I'm going to turn off the visibility. So if we used instead a flex conduit, let's come up here, let's look at our settings. I might have a piece of flex conduit that's 4-inch, all right? So this case, I'm using RMC 4-inch, but let's say I put in like a 4-inch pipe and put the metadata for a 4-inch pipe in there, and I'll hit save. And then I'm going to run a piece of flex conduit, And even though this is a flex conduit, I'm going to pick an edge. Let's start that again. Flex conduit. I want to pick this edge here because I got to pick an edge. And I'm going to pick, I guess, this edge back here. So what we get when we place this, we don't have the proper thickness for um, this piece of bus because it's going to have the metadata in that bus from the database. If you set up the database properly, of course, you set up the database so it shows that it's a bus pipe and has wall thickness or whatever, but the part's not going to have a wall thickness. And it's going to be a kind of a S band, and it's not going to be a true type of attachment there. It's not going to end properly. It's going to end wherever we picked it here, and it's going to pick it here as well. It's not going to end with an offset or anything like that. But we do have the tool to do this. So if I come in and delete that, I can, if I run the bus tool and run point to point, I'll always get an accurate piece of bus with a wall thickness since release, what is it, 9. Okay, so now what we're going to do, we're going to place a piece of bus from this elbow to this elbow. Remember, the axis, bus axis is shown. So we can only have the one bus axis. So if I pick two fittings to add bus, it's going to see that axis, and we're going to get an error. And you'll see that error here. The creation, I can't do the radius because what's actually happening is the bus is going to try and wrap around. It's going to come across here and loop all the way down to here. That's what it's trying to do, and it just can't do it. It knows it can't do that. So I'm going to delete that bus. And remember, when we use the delete tools up here, it deletes it from the Inventor environment as well as the Windows environment. So let's delete that bus. That's the bus I ran, and that's gone now. So I have that one bus suppressed. I have this bus run that I ran again, so we can delete another bus. I don't need this one. So let's go ahead and we'll run this with bus point to bus point. Now I want a negative offset on both sides. Remember, we want that negative offset. So now I come up to my bus. I'll copy this, and I really don't even have to copy the inch on the end of the second phrase, right? Because if you put these numbers in the Inventor parameter window, it's going to see it as that number. Oh, I think I should though. I am going to put it in. I just don't like not doing it. So I'm going to hit save. And now I'm going to place my piece of bus point to point, bus point to bus point. So now I come on here and I place that piece. And I have all my offsets correctly. The reason I was concerned with putting the inch on the back, just in case Inventor saw it through SDS as centimeters. I want to make sure it was an inch offset. So there we go. That's placing the bus using elbows, using just the one point for elbow. We got the one work axis, and we can do this. And what I often do when I'm making these, I would often come in here and make this group here as a subassembly because I might use it quite often, and I'll use it again and again and again. My last two slides are on the component placement chart, one for above grade, one for below grade. This one's the above grade, and you can see for linear length parts for cable and bus, it's the lowest common assembly. It's fitting the theme. Fittings are in the lowest assembly. Bolted circle connections, lowest assembly. Cable tap. Where we get a little bit different is bus end fittings and flex conduit are placed in the active assembly. What we also see is your selection and constraint type. If we look at the component chart, placement chart for below grade, conduit and trench and ground grid all are placed in this sketch containing assembly. So whatever assembly that contains a sketch, that's where those items are going to go. Ground leads are going to be placed in the active assembly, and this is where we want to be able to slide them, the ground leads, to the assembly you want them to be in. So often I will create my ground lead because I have to have my above grade to find where I connect to above grade and then go below grade with the with the lead. So they tend to be up in a higher assembly. So then I will slide them into my ground grid. Typically I put them in my ground grid. Ground tap, assembly containing the selected wire, which is usually the ground grid. Ground lug, lowest assembly. The ground lug is what we place on the bottom of a transformer or on a CCVT or item like that. Ground rod makes sense of placing it on the assembly containing the selected wire, which tends to be the ground grid. Conduit drop is placed in the active assembly. Most often you'd use it with the conduit drop tool on a above grade item like a control box or a transformer or circuit breaker, things like that. And below grade cable is placed in the active assembly. And that's basically because the selection for below grade cable has a lot of variables in it. You can pick a lot of different items for placing that below grade item.